Today's video we will discuss about the designing of irrigation canal. Okay, we have a question and we have to design irrigation canal with this given data. Okay, and before this video we have already done Resime numerical, okay, and one land canal numerical. So you have to see first that video, okay, and I will keep link of those video in description box. Okay, you can visit. So let's see the question first. Design an irrigation canal from a given data, and we have given discharge equal to 50 cubic, Manning's coefficient, that is eta equal to 0.025, critical velocity ratio, that is value of m equal to 0.99, and the slope s equal to 16 cm per kilometer. Okay, so this is given data and we have to design irrigation channel with the help of this data. Okay, so let's see the solution. Okay, so let's see, we have first the given value of discharge is 50 cubic, and you can say cubic is equal to meter cube per second, and the value of q equal to 50 meter cube per second, and we have given the slope is in other equations we have given generally the slope in this ratio form. Okay, but here in this video, in this numerical, we have given slope in cm and kilometer. Okay, so these two are the different unit, that's why we have to convert these two units in similar unit. Okay, so for this we have to convert cm into also meter, and this kilometer is also in meter. Okay, for this we have to divide with 1000 for the converting this cm into meter. Okay, and for this kilometer we have to divide 1000. And as we know, for the conversion of cm into meter we have to divide with 100. Okay, so we have to divide with 100, so this is 100, and for the converting kilometer in meter we have to multiply with 1000. Okay, so we just multiply with 1000. After calculating this value, we get the value of slope equal to 1:6250. Okay, so this is the value of slope, you can say s. Okay, s equal to 1:6250. Now we have to take first trial. Okay, for first trial let us assume the value of d equal to 2 meter, and we know the critical velocity, that is v naught equal to 0.55 md to the power 0.64. Okay, this is the basic formula for the critical velocity. Okay, and we have to just keep these all value in this formula. So 0.55, which is constant, and the value of m is given over here, m is equal to 0.99, and the value of d, we already assumed the value of d equal to 2 meter, so we just put this value here, 2 to the power 0.64. After calculating this value we get critical velocity, that is the value velocity v naught. Okay, v naught equal to 0.848 meter per second. Okay, so this is in meter per second. Okay, then it's okay. And now we have to calculate in second step area. Okay, and area can be calculated simply, we know as we know velocity equal to q by a. Okay, and also we can write the value of a equal to q by b. Okay, and here critical velocity is taken, that's why we use v naught. So the value of q is 50 given in the question. Okay, and the value of v naught we have already calculated, that is v naught equal to 0.848. so we just keep this value here, and we get the area equal to 58.98 meter square. Okay, and we already calculated the area equal to 58.98. okay, but we have the value of b is unknown. Okay, as we know, for the calculating area we use both b and d, but we already assume the value of d, that is 2 meter, but we have not known the value of b, that's why we have to calculate the value of b with the help of this area. Okay, so as we know, the area equal to BD plus half D square for the irrigation canal. Okay, for irrigation canal we use area equal to BD plus half D square. We have to know this formula. Okay, and we have given, and we have calculated value of A equal to 58.98 equal to B, and D we have already assumed the value of D equal to 2 meter. Okay, plus 1 by 2 D square, and same as this D equal to 2 square, and in this equation we have only unknown value is B, and after solving this equation we get the value of B equal to 28.463 meter. Okay. Now in third step we have to calculate the perimeter, and we know the perimeter P equal to B plus root under 5D. Okay, and we use these all calculated value. The value of B, that is we already calculated 28.46, we keep here, and root under 5 plus value of D, that is assumed value, and take on 2 meter. Okay, and we just keep 2 meter. After calculating this value we also get the perimeter, that is value of P equal to 32.935. Okay, now we have already known the value of A, P and B and D. Okay, so simply we can calculate the hydraulic mean depth, that is value of R. As we know, hydraulic radius, you can say hydraulic radius R equal to A by P, area by perimeter. So we have area equal to 58.98, we have already calculated here, you can see, and the value of P is also calculated 32.93. so we get the value of R equal to 1.78 meter. Okay, now in fourth step we have to calculate the actual mean velocity, that is the value of V. Okay, and as we know, the value of V equal to C root under RS. Okay, this formula is given by Kinley, and the velocity V equal to C root under RS, and the value of C is we have unknown. Okay, but we have the value of R, we already calculated. The value of R is 1.78, and also the slope is given over here in the question 1:6250, but we have only unknown value is C. Okay, for C we use the formula for the calculating value of C. We use this formula, C equal to 23 plus 1 by eta plus 0.00155 by 5 to the whole by 1 plus 23. This is plus 23 plus 0.00155 by 5 into n by root over r. Okay, and we have already this all value is known, 23 plus 1 by eta. The value of eta is already given in the question, that is 0.0225. Okay, so we just take this value plus 0.00155 by s, and the value of s is we already calculated 1 by 6250 here, 1 by 6250. Okay, so we just keep here, and 1 plus 23 plus 0.00155 by s, and s is also 1 by 6250 into eta by root under r, and the value of eta is also given in the question, that is 0.0225 as we already seen, and by the root over r, and the value of r is also calculated, that is value of r is 1.78, so we just keep 1.78, and after the calculating this value we get the value of C equal to 49.7. okay, and we have to use this value in this equation. Okay, so after calculating this value of C, we keep this value over here, so the value of velocity, that is B equal to 49.76, that is the velocity value of C root over RS. R, the value of R equal to 1.78, and the value of S, that is slope, is already calculated 1 by 6250, and this value becomes 0.84 meter per second. Okay, after calculating. Okay, and you can see here the actual mean velocity, you can say BA. Okay, actual mean velocity is nearly equal to this critical velocity. Okay, you can see here 0.84, and this is also in the 0.84. okay, so here nearly 2 digits are same. Okay, so this is the nearly equal velocity. we found nearly very near this value. Okay, that's why this value is okay. Okay, and we don't need to trial next trial. Okay, so this completes in very first trial. Okay, so this is all about this numerical. If the value of this actual mean velocity is not nearly equal to this critical velocity, then we have to do second trial. Okay, but here in this numerical, the value of both, that is critical velocity and actual velocity, is nearly equal. Okay, that's why we don't need for the second trial. Okay, and this completes the numerical. Thank you very much. See you in next video. Hope you guys are understand well. If you have any queries, please comment down below. Thank you very much. See you in next video. Okay, and I have uploaded different value related to our civil engineering as well this irrigation engineering, and different numerical related to our irrigation engineering. As you can see, design of Sada fall. Okay, design of guard bank, or you can say bail bond. Okay, and different numerical related to irrigation engineering, and that was very important for our final examination. So you can simply visit from the channel. Okay, thank you very much. See you in next video. One question: design an irrigation channel to carry a discharge of 50 cubic, and the discharge is given over here 50 cubic at a slope of 1 in 5000, and the slope is given 1:5000, and take the contours, that is the value of n equal to 0.0225, and the critical velocity ratio is given m equal to 0.9. Okay, so m is critical velocity ratio, and side slope is given 1:1. Okay, sorry, side we have given at a slope of 1:5000. Okay, so this slope is given. Okay, and this value is given in the question. Now we have to design a irrigation channel. Okay, and before this video we have already done design of irrigation channel in third numerical, and this is our fourth numerical related to irrigation canal. Okay, and as we discussed in last video, that is the value of critical velocity, that is the and this is denoted by V naught. And as I discussed in last video, the critical velocity, that is the V naught equal to 0.55 m y to the power 0.64. Okay, so this is the equation for the critical velocity. Okay, I can write here. So this is the equation of critical velocity. Equation of critical velocity. Okay, and we have given the value of m, that is m equal to 0.9. Okay, given in the question, you can see here. Okay, and the value of y is unknown, and 0.64. Okay, and after multiplying these two values, we get the critical velocity, that is the v naught equal to 0.495 y to the power 0.64. Okay, so this is the equation number 2. Okay, now as we discussed in last video, we have to calculate the value of a. Okay, and the value of a, area, can be simply calculated whenever the discharge and velocity is unknown. Then you can calculate area equal to q by v naught. Okay, and equal to q is given in the question, that is 50 cubic. So we just keep this value 50 by the v naught. Okay, and v naught is already known, that is the value of v naught 50 by v naught equal to 0.4, but in this equation we have the value of y is all unknown. Okay, so we just keep this equation as usual. Okay, and we have the equation for the area equal to by plus zy squared. Okay, and from this equation we can calculate the value of b equal to a minus zy squared by y. Okay, you can see here, and we have the value of z. Generally we take the side slope 1:1. Okay, so the value of z becomes 1. So for the area we use this formula, area equal to by plus z squared, Okay, and whenever we take the value of side slope, that is side slope equal to 1:1, simply the value of side slope becomes the value of z equal to 1. Okay, so after we taking 1, this becomes by plus y square. Okay, and after that we get the value of b, a minus y square by a. Okay, so this is the equation number 4. Okay, and this equation is third and in last video we have already discussed about the area. Okay, and in that numerical we have taken the value of a equal to bd plus half d square. You can say by plus half y square. Why in last video we taken the value of z is 1/2. Why we taken? It depends on the slope. Okay, whenever the slope is 1/2, we have to take 1/2, and whenever the slope is 1:1, then we have to take the value of z equal to 1. Okay, as in this numerical. Okay, so generally we prefer side slope equal to 1:1. So we take this value, and after solving this we get equation number 4. And now we know the value of p, that is the perimeter, equal to b into 2y root under 2. Okay, and you can see here the value of this. And now we have to calculate the perimeter, and the perimeter equal to b plus 2y root under 2. Okay, so this is here plus. Okay, so the value of perimeter equal to b plus 2y root under 2, and whenever we multiply this 2 with the root under 2, the value becomes 2.83 and y as usual. Okay, and this value of perimeters becomes in the equation 5. Okay, now we have to calculate the value of hydraulic mean radius, and you can say simply r. I will write here hydraulic mean radius, that is value of r equal to a by p. Okay, so this is all about we have to calculate parameter. Okay, now we see the formula given by the Cotter's formula. Okay, and we know the formula is given by the Cotter's is v equal to c root under rs. Okay, c root under rs, and the value of c is this. Okay, this is the value of c, 1 by 0.225 plus 23, as we done in last numerical. I will show you here. Okay, so we have the value of c, as we said, actual mean velocity v equal to c root under rs, and the value of c equal to 23 plus 1 by eta plus 0.00155 by s. Okay, and by 1 plus 23 plus 0.00155 by s into n by root over r. Okay, so this is the determining the constant, that is value of c. Okay, in the equation of actual mean velocity, that is va. Okay, so this is the value of s. You can I will just write like this. Okay, and this is also as we calculated, this is the value of eta. Okay, eta by root under r. Okay, eta by root over r and into root under rs. So this is the basic formula of the given by the Cotter's. Okay, and v equal to c root under rs. And now we have to assume the value of y and proceeding with successive trial form. In last video we have got the value of b in very first trial, but in this numerical, let's see. So now we have to calculate this all parameter with the help of this different equation. Okay, we have given provided the equation is here. Now let's see in very first trial. We have in very first trial number 1. Okay, the value of y is taken 1, and the value of b naught. Okay, that is the when we take the value of b naught equal to, when you take the value of y equal to 1 in this equation. Okay, then the value of b naught becomes 0.495. Okay, and for the help of this we can calculate the area. area equal to 50 by V naught, and the value of V naught is taken 101.01. Then we get the value of A equal to the value of V naught equal to 0.495. Then we get the value of A equal to 101.01. Okay, with the help of this equation. Okay, and after that we have the value of B equal to from with the help of this equation. Okay, and we have already calculated the value of A, and the value of Y is already taken 1, and this is also 1. Then the B value of B becomes 100.01. Then we have to calculate the perimeter. P equal to B plus 2.83y. Okay, and the value of B is already known, that is the value of B equal to 100.01 and plus 2.8 into 3y, and Y, the value of Y equals taken 1. Okay, so we can calculate easily the value of P, and after that we have to calculate the value of R, that is hydraulic radius equal to A by P. Okay, and we have already calculated the value of A and P. A is the 101.01 and the value of P equal to 102.8. So the value of B becomes 0.621. Okay, and in this you can see we have the value of B equal to 0.621. So this is far difference. Okay, far difference from each other. Okay, that's why the remark is B naught is not equal to V. Okay, then we have to perform second trial. Okay, and whenever we take the second trial, we have to increase the value of Y. So instead of 1, value of Y equal to 1 in very first trial, and in second trial we have to take the value of Y with increasing before this value. Okay, so we just take the value of Y equal to 2. After taking the value of Y 2, we get the value of V naught with the help of this equation, as I said. Okay, whenever we take the value of Y equal to 2, this value V naught becomes 0.770, and now we have to calculate the value of A. Okay, and A becomes 50 by B naught. B naught we already calculated 0.7. Then the value of A becomes 64.819, and the value of B equal to A minus Y squared by 2. And the value of Y we have to take 2, and A area we already calculated, that is 64.819. So we have to just keep this value over here in this equation. Then we can calculate the value of P, B, and also value of P. P with the help of this we have already calculated B and Y. B, and with the help of this Y we get the value of R equal to 1.797, P equal to 36.07 with the help of this equation. Okay, and finally we can calculate the value of this actual velocity, that is B equal to with the help of this formula. Okay, and we have already known different parameters, that is the value of R and S. We have already calculated the value of R is over here. Okay, in this way in second trial the actual velocity becomes 0.94. Okay, so you can see this is also very difference. Okay, with the critical velocity 0.770, and this becomes 0.94. So we have to perform third trial, and in third trial similarly we take the value of Y equal to 3. Then the value of B naught becomes 1 with the help of above equation. A equal to 50.004, as we discussed before. The value of B equal to 13.6, P equal to 22.15, R equal to 2.257, and the B equal to 1.094. Okay, so you can see here this is also not nearly equal. Okay, so this is a far difference. So the remarks we have to write over here, V naught does not equal to V. Okay, so now we have to perform next trial. So in trial number 4 we have to take the value of Y equal to 3.5. Okay, you can take this value by increasing 1, or you can take 0.5. Okay, it's your choice. And in trial number 4 we have to take the value of 3.5. Then the V naught equal to 1.104, A equal to 45.307, B equal to 9.4, P equal to 9.3, R equal to 2.3, V equal to 1.12, and this is also the 1.121, and this is 1.104, so we have matchable value. Okay, but we have only one value matched after the point. You can see 1.1 and 1.1, but whenever we have matched two value, okay, that is after the this point value, that is in this video you can see here 1.12, and in this also 1.12, then the value then our trial will be okay, and we will stop. But here you can see only one value are matchable after the point, so we have to perform next trial. Okay, in next trial let's take the value of y equal to 3.6, because this is nearly equal to, so we just increase the value of y is very small, say 3.6. then value of b not equal to 1.12, a equal to 44.497, and b equal to 8.7, p equal to 18.94, r equal to 2.3, and b equal to 1.29. Okay, so you can see here in this trial this actual velocity equal to 1.12. Okay, and critical velocity is also 1.12. Okay, so these two value are very nearly equal to. Okay, and the remarks become v naught equal to b naught is nearly equal to b. Okay, that's why we stop now performing the next trial. Okay, and this completes our numerical. Okay, and whenever the value of critical velocity, that is the value of b naught, is nearly equal to v, that is the actual velocity, you can say after the point we have matched two digit, then our numerical will be we get exact value that we want. Okay, and after that we will stop the next trial. Okay, so this is all about determining the value and performing the trial. I have already explained in very detail. If you can't able to understand, please you can back this video and you can easily understand. Okay, I have already explained in very detail. Thank you very much. If you guys are understand, please do like, share and subscribe the channel. Thank you very much. See you in next video. Okay, and please like the video. Thank you very much. Okay, define Resime channel. Okay, this is definition part. And design and trapezoidal canal with a side slope 0.5 h is to 1b. We have given the side slope 0.5 is to 1. Okay, in horizontal 0.5 and in vertical 1. To carry 7.5 cumecs of a discharge, and the discharge is given over here 5 cumecs. Okay, and you can say 5 meter cube per second. The canal is to be laid at a slope of 1 in 3000, and the slope of canal is given 1 is to 3000, and the critical velocity ratio for the soil is taken 1.1. Okay, and use the cutters rigidity coefficient as 0.023. Okay, so this all parameter is given in the question. Okay, now we have to design the trapezoidal canal. Okay, and before this video we already designed I will show you here. We will already done the numerical related to the design of irrigation canal. Okay, that was our third numerical, and in fourth numerical we have also done the fourth numerical. You can see here this numerical. Okay, before this video we have already done this numerical. Okay, similar to this numerical. Okay, so if you have not seen this numerical, you have to first see this solution. Okay, then after you can see this numerical. Okay, then you can easily understand each and every term. Okay, because in last video we have already performed different trial. Okay, with the help of this different equation, so you can easily understand this numerical if you see the last video. Okay, and I will keep the link in description box as well. Now we have given the this parameter discharge equal to 5 meter cube per second, and the slope, side slope is given 0.5 h is to 1b. Okay, and these parameters is given. M is the critical velocity ratio. Okay, and the value of m is also given 0.2. So these all parameters are given by the question. Now we have to design trapezoidal canal. Okay, so very first step, as we already discussed in last video, we have to calculate the value of critical velocity. Okay, for the critical velocity, we use the formula 0.55, and that's again v naught equal to 0.55 m into y to the power 0.64. This is the critical velocity. Okay, so we have this formula for the critical velocity, and just we keep the value of m given in the question, that is the value of m equal to 1.1 given by the question, and y is not given. Okay, so we just keep the value of y as usual. So the critical velocity, that is the value of v naught becomes 0.605 y to the power 0.64. So let's assume this is the equation number 1. Okay, now if the critical velocity is known, then we can calculate the area. As we know, the area equal to q by v. Okay, or you can say also velocity equal to q by a. Okay, so you can you must know this formula. Okay, and we are use this formula many times. Okay, so we have the value of v naught. This is also unknown in the equation form. So we just left v naught, and this is equation number 2. And we know the value of a for the trapezoidal canal. We know the area is taken a equal to b plus y by 2 into y. Okay, for a trapezoidal canal, and this value becomes by plus y square by 2, as we already used in the case in the question number 3rd. Okay, we use area equal to bd plus half d square, or you can say by plus half y square. Okay, so this is also case of trapezoidal canal. So we just use this formula by plus y square by 2, and you can say y, or you can write d. Okay, but in this we just say this is y, and the value of a becomes this, and from this equation we can calculate the value of b equal to a minus y square by 2 by the y. Okay, and y square by 2 simply taken 0.5 y square. Okay, so let's assume this is the equation number 3rd. Now we have to calculate the value of p. Simply you can say p is the perimeter. Okay, and as you know, the perimeter of trapezoidal canal, that is the p equal to b plus root under 5y. Okay, so let's assume this is the equation number 4. Okay, now we have to known the value of area and perimeter. If the value of area and perimeter is known, we have to calculate the value of r, and the value of r is taken r equal to a by p. Okay, so you can say you can write this equation like this by plus 0.5 y square by the perimeter b plus root under 5y. Okay, so you can write like this. Okay, so let's assume this is the equation number 5. Okay, so we have basically 5 different equations. Now we have to use the formula given by the Cotter's formula. Okay, b equal to this formula we already discussed. b equal to c root over rs. Okay, so this is the formula given by the Cotter's. Okay, and you can see here the value of c equal to 1 by n, you can say n, or 1 by eta plus 23 plus 0.0155 by s by 1 plus 23 plus 0.00155 by s into n by root over r. Okay, so this equation is given by the Cotter's. Okay, that's why this is called Cotter's formula, and with the help of this formula we can calculate the value of b, and you can say the actual velocity. Okay, with the help of this. Okay, and we can calculate the value of c with the help of this equation. Okay, and now let's proceed the different trial. Now assume y and proceeding below this value. I will just make the table, then you can this will be easy to understand. Okay, I have made this table. Okay, now we have to take a different value of y and proceeding this all equation. Okay, and with the help of these all equations we can calculate this all value. Okay, so you can see here in very first cell we have to take the value of n. Sorry, the value of n is already given in the question. Okay, we have to take the value of y. Okay, and the value of y, this is, I think this is the y, sorry, this is the y. Okay, and this is b naught, that is the critical velocity. This is area, b equal to this, you can say in equation number third, the area we can calculate with the help of this equation number 2. And perimeter, for the perimeter we use this formula, equation number 4. For the value of r we use this 5, and as I already told, r is the hydraulic radius. Okay, and b is the actual velocity given by this equation, that is the equation given by the Quaries, and we use this actual velocity formula for determining the actual velocity, and this is the remark. Okay, and in remark we have to compare the value of this actual velocity and this critical velocity. If these two value, that is the actual value, is nearly equal to critical velocity, then we have to stop the trial. Okay, and until these two value is not equal, then we have to proceed on next trial. Okay, so let's see. In very first trial, let's assume the value of y. You have to assume the value of y in difference of you can take 0.1 as well. Okay, or you can take 0.7, but we have to take the value of y in a very small gap. Okay, and we have to increase the value of y according to the given calculated value of this. Okay, so let's see. In very first trial, the value of y is 0.7. Okay, whenever we take the value of y equal to 0.7, then we can calculate the value of v naught with the help of equation number 1. That is the, we have to put the value of y equal to 0.7, then we get the value of b naught equal to 0.482. Okay, then we have to calculate the value of a with the help of equation number this 2, equation number 2. This is the equation of 5 by b naught. Okay, a equal to 5 by b naught. I have already written this. We have to use for the a equal to 5 by b naught, and the b naught is already known, so we can simply calculate the area equal to 10.38, and b equal to a minus 0.5 y square by y. The value of a is already calculated 10.3, and the value of y is taken 0.7, so the value of b becomes 14.4. Now perimeter p equal to b plus root under 5y. B is already calculated this value, and y is already taken 0.7, so the value of p becomes from equation number 4 16.04. Now we have to calculate the value of r equal to a by p. A is already calculated and p is already calculated, so we have to just divide a by p. We don't have to do this equation. Okay, you can simply use r equal to a by p, and the value of a is already calculated and the value of p is also already calculated, so we just have to use these two value for the calculating of r. So r value becomes 0.647. Now we have to calculate the actual velocity, and the actual velocity is given by this equation. Okay, and simply we use this formula root under rs. We already calculated the value of r, and we have already this s equal to 1:4000. So after putting these all value in this equation, we get the value of b equal to 0.504. Okay, so you can see here we have to compare the value of this b with this b naught. This is actual velocity and this is critical velocity. Okay, so you can see here this is not matching these two value. After the point we can see this is 5 and this is 4. Whenever after the this point the two digits are similar, then we have to stop the trial. Okay, then the value of v naught equal to b, then okay, until we get the value of two digits similar, then we have to trial next to next. Okay, so this is not equal to remarks b naught is not equal to b, so we have to increase the value of y. So let's increase the value of y equal to 0.8. Then we get the value of b net equal to 0.524 as in first trial. A equal to 9.5, b equal to 11.56, b equal to 13.3, r equal to 0.7, b equal to 0.54. This all value can be calculated similarly in the first trial, as I said, with the help of this all equation. Okay, then the value of b becomes 0.54. You can see here this is the 0.52. So I already said we need two value matching after the point. Okay, so you can see here one value is already matching. Now we have to match second value. Okay, for this remarks is also b not is not equal to b. Then we have to calculate. Then we have to proceed next trial and proceed third trial. For this we increase the value of y as 0.9. Then you can calculate b not equal to 0.5, a equal to 8.8, b equal to 9.3, p equal to 11.3, r equal to 0.7, b equal to 0.5. Okay, so you can see here this value is nearly equal. Okay, but after the point two digits are not matched. This is 0.57 and this is 0.56. Okay, so we have to write in remark b not equal to b. Okay, so we have to perform next trial. So in trial number 4 we have to take the value of y equal to 0.95. Okay, or you can take the value of 1, but we're not taking the value of 1. Why? Because you can see here this value is nearly equal to, okay, these two values are nearly very equal. That's why we have to increase value of y in very small. Okay, so we just increase the value 0.9 to 0.95. Then the value of b naught becomes 0.58, a equal to 8.5, b equal to 8.5. And as I explained in very first trial, this all parameter can be calculated with the help of this all equation. Okay, we have already 5 equations. Okay, with the help of these equations we already calculated these all parameter 1 2 3 4 5. With the help of these 5 equations we can calculate these 5 parameters. Okay, and value of b equal to 8.5, p equal to 10.63, r equal to 0.8, b equal to 0.588, and remark you can see here this value becomes 0.58, and after the point you can see here 0.58, two digits are similar to the critical velocity, that is 0.58. Okay, so after matching two digits after the point, then our trial will be stopped. Okay, and in remarks you can write b not equal to b, that is the critical velocity is nearly equal to actual velocity. Okay, then we have to stop the trial and hence adopt the value of y equal to 0.95 and the value of b we already calculated 8.515. Okay, so this is our answer. Okay, in this way we can easily proceed different trial, and we have to proceed next to next trial until the value of b naught, that is the critical velocity, is not equal to actual velocity. Okay, and whenever these two value nearly equals, or you can say after the point value when two digits are matchable, then we have to stop the trial. Okay, so this is all about this numerical design of this trapezoidal canal. Okay, so this is our fifth numerical related to design of canal. Okay, and if you see all the numerical that I have done from 1 to this fifth number numerical, you can easily understand any question related to designing of canal. Okay, so this is all about our designing of irrigation canal. Okay, and we already solved the numerical related to the Resime Canal, trapezoidal canal, line canal. Okay, and different numerical related to designing of irrigation canal. Okay, so you have to see all the numerical, and I will keep the link of all those numerical in the description box. You can click from here. Thank you very much. If you like the video, please do like, share and subscribe the channel. Okay, thank you very much. See you in next video. Have a good day.